Okay. Can you see module 2 questions? Are you able to see the screen?
Yes, sir.
Okay, which one we have taken? Effect of mean stress and microstructure on SN behavior. This I think we completed, no? Did we complete this? I think you were not present that day, probably. Correct?
No, sir. First question have been completed.
Completed the first question?
Yes, sir.
Yes, sir, we have done.
Okay. Okay, this is a strain-based approach to life estimation.
No, sir. Should I?
No, sir, we have not done that.
Yeah. So what we'll do, take these questions first. Describe strain-based approach to life estimation. Explain the effect of following on SN behavior. That is second question. Explain procedure for estimating fatigue failure criteria. And last one is explain the following: strain life curve, transition fatigue life, mean stress effects on strain life. Okay. Note down these three. These one, two, three, four questions. Okay. Please note down these four questions first. Describe the strain-based approach to life estimation. Explain the effect of the following on SN behavior: microstructure, surface finish, sheet treatment.
We have written this question, sir. Answer also.
When? This
The last
question,
class, sir.
this we have finished.
Yes, sir. Seventh question we have done.
Oh,
Yes, sir.
that's completed.
No, sir. We wrote off. Not full, sir.
Yes, sir. It's.
No, have you completed or not?
You told us to.
No, sir.
Okay, that you have finished. No, then. So take a strain-based approach to life estimation and then take these two questions, 9 and 13. Just note down these two questions. Fourth one, have you noted? Describe a strain-based approach to life estimation.
Yes, sir.
Noted. So note down 9 and 13. Finished, huh? Finished noting down these two questions. Hope you have finished. Strain-based approach to life estimation. So that we'll see now. Strain-based estimation. Okay. Strain-based approach. Okay. Can you see this now? Strain-based approach to life estimation. Can you see the screen? Strain-based approach to life estimation.
Yes, sir.
Yes, sir.
Okay. So before that, what we learned is some monotonic tension test, wherein we learned about the nominal stress. Nominal stress will have A0 is the original area of cross section, that is calculation of stress based on original area of cross section of the specimen is called nominal stress. When we use instantaneous area of cross section, that is area of cross section of the specimen at that particular instant, okay, then it is called true stress. Similarly, we have engineering strain and two strain, where Li stands for instantaneous gauge length. See, originally we'll have one gauge length. So as the specimen gets deformed, this gauge length will differ. Okay, so it will change in its value. So when we use instantaneous gauge length, then it is called a true strain. And then after that, so for short strain, we can say engineering stress and strain will be equal to true stress and strain. And then later on, we went on to learn about resilience and tensile toughness. So toughness is the energy per unit volume absorbed during deformation up to fracture, and is equal to total area under the engineering stress strain curve. Is anybody coming there? Okay. Okay, and then we learnt about the strain controlled test method. So we learnt about the specimen that is used. Okay, so now coming to strain based approach to life estimation. So what is the difference? Strain can be measured, but whereas stress is calculated, okay, based on the deformation and based on the area of cross section, which is constantly changing till the failure. But whereas strain can be measured, and strain is a good quantity for correlating with low cycle fatigue. That is, this fatigue that is below 10 power 4 number of cycles, that is failure that occurs below 10 power 4 number of cycles, then the strain based approach is a good approximation, good approach in fact. And gas turbines. So he has taken an example where gas turbines operates at fairly steady stresses, but when they are started and stopped, they are subjected to very high stress range. So this is common for many of the engines, including the gears. That is, starting torques will be much higher than running torques in case of gears also. So same thing holds good for many components, where there is a starting and stopping are happen frequently. Okay, as I said, stresses are more difficult to measure or estimate than strains. So strain, we have got lot many instruments, so we can just mount the instruments at appropriate places and then extract the values of strains. And in a notched component subjected to cyclic external loads, the behavior of materials at the root of the notch is best considered in terms of strain. So at the root of the notch, so it is better to have strain. And strain based design method can be used for relating fatigue of notched part to life of small unnotched specimens that are cycled to the same strengths as the material at natural. So fatigue damage is assessed directly in terms of local strain. This approach is also called local strain observed. That is, whenever there is a presence of discontinuity in the form of a notch or a hole, okay. So around this discontinuity, which is generally taken as notch, so around this notch, the strain can be measured. Okay, so this will give us the accurate picture of fatigue failure. Okay, and since the fatigue damage is assessed directly near the notch, that is around this notch, in terms of local strain, this approach is also called local strain approach. Okay, so a reasonable expected fatigue life can be based on nucleation and for or formation of small microcracks can be determined if one knows local strain. Okay, local strain time history at a notch in a component and unnotched life fatigue properties of the material. So strain life curves are often called low cycle fatigue data because of data are far fewer than 10 power 5 number of cycles. And also strain life fatigue, okay, it consists of elastic strain and plastic strain. So you can write up to that, and then we can go for transition fatigue life. What is transition fatigue life, and what is elastic strain and plastic strain? So for strain based approach to life estimation, so we can say strain can be measured, or if you want to take further beyond before, so what you can tell is you can talk about the true stress and true strain, then engineering strain and true strain, then come to the total true strain. You can equate it as equal to elastic strain plus plastic strain, and then from there you can come to directly to strain based approach to life estimation, and then you can discuss about strain can be measured. It's a good quantity. Give an example of gas turbine, or you can give an example of gears during starting torque, because starting torques in case of gears are much higher than running torques. You can talk about gears as well, okay, as the example. And then you talk about notch. So around the notch, so notch can be in the form of a hole or in the form of a groove, or it can be in the form of a stepper shaft, or it can be in the form of slots. So they call for those discontinuities in general as notch. So around the notch we can find the strain. Okay, around the notch we can find out the strain. So therefore this approach is also called the local strain approach. Is that okay? This is about strain based approach to life estimation. Okay, so please note down this much into your sheet now. Are you there? If you have this PPT of module 2, so open it and you can write it down. So write down this. Are you still able to see the screen of PPT?
Yes, sir.
Okay. After completion, you please let me know. ರೆಡ್ಡಿ ಒಳ್ಳೆ ಟೈಮಿಗೆ ಬಂದ್ರಪ್ಪ ಇಲ್ಲಿ. ಸೊ ಐಲ್ ಪುಟ್ ಗ್ರೇಡ್ ಆಸ್ 30 ಆದ್ಮೇಲೆ ರಿಟರ್ನ್ ಹೊಡಿಬೇಕಾ ಸೇವಿಂಗಿಗೆ?
ಇಲ್ಲಿ ಕ್ವಶನ್ಗೆ ಆಗ್ತಾ ಇಲ್ಲ.
ಅದ್ ಬಿಡಿ, ಆಮೇಲೆ ಹಾಕೋಣ.
ಹಾಕ್ಬಿಡಿ, ಮತ್ತೆ ಮರ್ತು ಹೋಗ್ತೀರಾ.
ಬಿಡ್ರಿ, ಅದೇನ್ ಬೇಕಿಲ್ಲ, ಅಷ್ಟೆಲ್ಲ ಏನ್ ಬೇಕಿಲ್ಲ.
ಜೂಮ್ ಮಾಡ್ಕೊಂಡ್ರೆ
ಅಲ್ಲ, ಅದಕ್ಕೆ ಈಗ ರಿಟರ್ನ್ ಹೊಡಿಬೇಕಾ ಏನು ಅದು ಸೇವ್ ಆಗಕ್ಕೆ?
ರಿಟರ್ನ್ ಹಾಕಿ
ಅದನ್ನ ಜಸ್ಟ್ ಕ್ಲೋಸ್ ಮಾಡೋದಾ? ಓಕೆ, ಹೆಂಗೆ ಕ್ಲೋಸ್ ಮಾಡೋದು?
ಎಲ್ಲ ಸ್ಕ್ರಿಪ್ಟ್ಸ್ ಮಾಡಿದಲ್ಲ.
ಇಲ್ಲ, ಇದು ಸೇವ್ ಆಗಿದೆಯಾ? ಓ, ಇಲ್ಲಿ ಹೋಗ್ಬೋದ ಇನ್ನೊಂದಕ್ಕೆ ಸ್ಟ್ರೈಟ್? ಸೊ ಸ್ಟ್ರೈಟ್, ಐ ನೀಡ್ ನಾಟ್ ರೈಟ್ ಆಲ್ ದೀಸ್ ಥಿಂಗ್ಸ್. ಸೊ ಇಟ್ ಇಸ್ ಜಸ್ಟ್ ಜಿಫಿ, ಜಸ್ಟ್ ಟರ ಮಾಡೋದು, ಕಳಿಸ್ತಾ ಇರೋದು.
ಏನು ಇದನ್ನ ಶೇರ್
ಅಲ್ಲ, ಅದು ಬೇರೆ ನಡೀತಾ ಇದೆ, ಮೀಟ್ ಗೂಗಲ್ ನಡೀತಾ ಇದೆ.
ನಮಸ್ಕಾರ.
ಇದ್ಯಾವುದು
ಕ್ಲಾಸ್ ಅದು.
ಇದನ್ನ ಐ ಕ್ಯಾನ್ ಕ್ಲೋಸ್, ನೋ? ಓಕೆ, ಸೊ ಜಸ್ಟ್ ಎಂಟರ್ ಹಿಯರ್ ಅಂಡ್ ದೆನ್ ಕ್ಲೋಸ್.
30
ಕಲಿಕ್
ಭಾಷಾ
ಅನಂತ್ ಕೃಷ್ಣ ಸರ್.
Que ulanjes, me lo mismo papel no te dice que Ricardo es nada. Google Meet. Mari.
This will not come, no?
Vasun Same.
How it will come? See, I am sharing their this one. They are seeing this PPT.
No, when you minimize this, that will
No, after it will not come in Google Meet. Unless otherwise, I go here.
Sir, phone just come.
I called, no? Mithun, what you are seeing? Which one you are seeing on your screen?
Strain base
Approach to life estimation, no?
Minimize.
Yes, sir.
Minimize it. Wait, now,
One more window you open.
okay. See, I am opening. Now also you are seeing the same thing, no, Mithun?
yeah, yes sir.
Then you window share chesnada only this share chesnada.
Window.
Screen share చేసింటే ఇదంతా వెయిట్.
No, I go for window.
విండో అయితే అదొక్కటే పోతుంది, ఆ విండో ఒకటే పోతుంది.
ఎట్లా?
రికార్డ్ అవుతుంది సామాన్యుడికి. మాకు రికార్డ్ అవుతుంది. క్లాస్ 1 ఉంటాం.
10:30. Finished with this? Finished writing this?
Yes,
Finished?
sir.
Yeah? Okay. So take down this. So reasonable expected fatigue life based on the formation of small macro cracks can then be determined if one knows the local strain time history at a notch that is near a hole or a groove or a slot or a keyway, okay, in a component, and then we can predict the fatigue life of the component. And strain life curves are often called as low cycle fatigue data because much of the data are fewer than 10 power 4 or 10 power 5 number of cycles. Please note down this much. Finished with this question? Okay?
Yes, sir.
Okay. Next question is explain the procedure for estimating fatigue failure criteria. Okay? Procedure for finding fatigue life criteria. Okay, so for this, you need to go to first set of PPT in module 2, where you have got SN curve representation and approximations. So using Baskin's equations, modified Goodman and Morrow equations, we can calculate the fatigue life, okay, of components. Hope you remember. Anyway, I'll put that on the screen. Okay. So here. Okay. Can you see this SN curve representation and approximation? Can you see this screen?
Yes, sir.
Yes, sir.
Okay. So how to calculate fatigue life? You need to go through this unnotched specimen, notched parts, and use the equation of fatigue life, Baskin's equation, and then we can use Goodman and Morrow equations to calculate, and for repeated loads, fully reversed loads. Okay. So we can use these equations to calculate fatigue life of a specimen. Okay. So this you extract from your PPT. Then I explain the following: strain life curve, transition fatigue life, mean specific ton, strain life. So this is what is the next one. So for that, transition fatigue life, we just saw that. Yeah. So this is transition fatigue life. Okay. So strain life fatigue curves are plotted on log scales, and then we have two. It can be resolved into two. One is elastic strain and plastic strain. So at large strains, plastic strain component is predominant because the deformation or yielding takes place. At small strains or longer lives, elastic strain component is predominant. Okay. So there is a plastic strain where the failure is going to be faster. So this is essential refers to brittle materials. Small strains are longer lives. This is essentially for ductile materials where you will have elastic strain components. Okay, at a point where the failure number of cycles required for failure both in plastic strain as well as elastic strain is going to be the same, so that point is called transition fatigue life. Okay, that is the life at which elastic and plastic components of strain are equal is called transition fatigue life. Okay, this is what you need to write. And for lives less than 2 nf, the deformation is mainly plastic, but that is it's going to fail at a very less number of cycles. For the lives greater than 2 nf, the deformation is mainly elastic because it takes more number of cycles of failure. And the transition fatigue like decreases with increasing hardness. So more the hardness, it's going to be the brittle material, and faster is the failure. And strain-based approach unifies the treatment of low cycle and high cycle fatigue. So this is what strain life fatigue properties, determination of strain life fatigue properties. So this is what you need to write for the earlier question. Okay. And then for this present fatigue, transition fatigue life, you need to talk about the strain life fatigue curve, you need to talk about elastic strain and plastic strain, and then we need to talk about transition fatigue life, its definition. And this graph and this pitch figure is very essential. Is that okay? Okay? Are you there?
Yes, sir.
And I think that's all in this strain life curve that you will take anyway, mean stress effects on strain life. So mean stress effects have we taken? Let's see. Mean stress effects on strain life. Yeah. Okay. So this is the mean stress effects on strain life. This is the spring regarding, we discussed about relaxation of bike stand spring and so on. Okay, that happens because of repeated application of load. So mean strain can be present, strain controlled cycling. So this mean stress is equal to mean strain into Young's modulus, which may relax fully or partially with continued cycling. This relaxation is due to the presence of plastic deformation. So we discussed about a bike stand spring where the stand will not go back as it does in the beginning. Later on, once you use the bike stand for 2 or 3 years, the stand will not go back to its position quicker because the spring that is attached to the bike stand would have lost its stiffness. Okay, that is, it would have become relaxed. Okay, this is due to the presence of plastic deformation. So that is the effect of mean stress on the strain life fatigue. Okay, and also mean strain does not usually affect fatigue behavior unless it results in non-fully relaxed mean stress. So this there is more mean stress relaxation at higher strain amplitudes due to larger plastic strains. Okay, and the rate of or amount of relaxation depends on magnitude of plastic strain amplitude. So this is what you need to write about the effect of mean stress at longer life, mean stress on effect of mean stress on strain based life. Is that okay? And you have to talk about SWT parameter as well, that is Smith, Watson and Topper param called SWT parameter. So we need to talk about up to that. Okay, that is for the question on mean stress effects on strain life. Mean stress effects on strain life, we need to discuss about mean stress relaxation. Okay, there's mean stress effect over here on strain life. Okay, we need to discuss about this. We need to discuss about this, and we need to write about this up to SWT parameter. Is that okay? Are you there? So what you do is complete this much, and then submit it. So probably you write maybe by Wednesday you submit module 2 after completion. Is that okay?
Okay, sir.
Yes, sir.
Is that fine? So
Yes, sir.
complete whatever questions that you have taken in module 2 and submit it